Okay, so this exercise is based off the triangle problem. So I'm going to just make this as a separate example. And what you do is you look at the rules and you apply them in the order they're given. And you look at the examples and make sure you understand the rules. And then you try to calculate the remaining exercises. So rule 1 says, this is a funny, like a dinosaur foot or a cat paw or something, whatever it's, or a flower. But it's a function with 4 inputs. And it turns out that this one right here is controlling what the other 3 do. So if you get 0 down at the bottom, you just add the other 3 values. Great. Rule 2 says, if there's anything other than 0 here, you just decrease by 1. And then you put that value down there. So it's just counting down 1, 2, or 3, 2, 1, 0, whatever. It's counting down. And the other thing you do is you take this first value and you double it. Okay, so you do that. And then these other 2 values, you take y, subtract 1, and put it in the other input. So the one that was y becomes z, but it's down by 1. And the one that was z becomes y, but it goes down by 2. This is a great deal easier than the other function problem you had, so I thought I would give it to you just to give you a little variety. Okay, and then I think you can see what's happening here. In each step, you're guaranteed that this number is going to decrease by 1. It tells you right away how many steps you're going to take, and then you just have to worry about all the other jiggering around. The other thing that's really easy about this function is you just always know that this guy is going to double until this guy goes down to 0. So this guy is doubling, 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 doubling until this gets down to 0. So all that is easy. And then what you do is you just make sure that the other rule is satisfied. So this middle guy becomes the right-hand guy and it's down by 1. Middle guy becomes the right-hand guy and it goes down by 1. Great. Middle guy becomes the right-hand guy. Middle guy becomes the right-hand guy, middle guy becomes the right-hand guy, and you see in these examples that it's totally fine to have negative numbers in these problems. And the right-hand guy becomes the middle guy, but it goes down by 2, right becomes middle, goes down by 2, right becomes middle, goes down by 2, right becomes middle, goes down by 2, and so forth. So we just verified that everything works out, and then the final step is to add the little spikies together. Fine. So how do we do this first problem? And as you see on my answer key, I didn't want to draw out all those little spikies, so I just made the letter V, and I put the 2 down in the crook, and then the 3 numbers I just sort of spread out. It's totally fine to simplify your artwork for the sake of simplicity. So this is a down counter, so you can already tell that you're going to go down, down, and then add all the peaks together. And you know this 1 is going to become 2, which is going to become 4. Now what? This middle guy, you subtract 1 and move him over. And the right guy, you subtract 2 and move it to the middle. Okay, so we've got that. Middle guy, you subtract 1 and put him over here. This guy, you subtract 2 and put him over there. There you go. Let's try the next one. Again, I'm just simplifying by writing the next step down here. Double 3 and get 6. Subtract 1 from 2 and get 1. Subtract 2 from 4 and get 2. Double 6. Subtract 1 from 2. Subtract 2 from 1. And this is almost done. 20. So I'm going to put commas between there. Subtract 1 from -1 and get -2. Subtract 2 from -1 and get, subtract 2 from 1 and get -1. So you should get 21. Okay, so what about C? C, 2 becomes 1, 7 becomes 14, 8 becomes, 7, 9 becomes 7. And 14 becomes 28, 7 becomes 6, and the other 7 becomes 5. Okay, so this 28 plus 11 is 39. Okay, and just to keep my screen clear so you can see everything at the same time, I'm going to erase these and reuse this space. Okay, D. Okay, 5 becomes 10, 3 becomes 2, 7 becomes 5, 10 becomes 20, 5 becomes 4, 2 becomes 2, 20 becomes 40, 2 becomes 1, 4 becomes 2, 40 becomes 80, 2 becomes 1 becomes negative 1, and then this becomes 80. Okay, so I made a mistake. Where did I make my mistake? So I went back and looked at my answer key and saw that I made a mistake. And so let's figure out what happened. 10, 20, 40, 80, that's good. 5 becomes 4, that's good. But what happened? 2 became 2. Bad deal. I forgot to subtract. Alright, now let's see if that error trickles down. It does. 0 becomes negative 1. 4 still becomes 2. 2 becomes 1, but negative 1 should become negative 3. And so it's going to be 78. Okay, right about E. 4, you can just fill in all these if you want. 4, 8, 16, 32, 64, and let's see what happens next. 8 becomes 7, 10 becomes 9, 9 becomes 8, 7 becomes 5, 5 becomes 4, 8 becomes 6, 6 becomes 5, 4 becomes 2, 2 becomes 1, 5 becomes 3, and so this should be 68. Let me go check that. Okay, so I messed that one up. Okay, let's fix it. 10 did not become 9. 10 is supposed to become 8. So 8 should become 7. 7 should become 5. 5 should become 4. 4 should become 2. Let me try that one. Okay, so you see how important it is to check your work, and of course it's unfortunate for you, you don't have the answer key. But my answer key was wrong too. So the point is you have to do these things twice, preferably on a clean sheet of paper, and then compare your work against your own work, and then if there's a discrepancy, now keep working until you figure out where the error is. Okay, so let's see. 3, 6, 12, 24. Alright, so what do? 9 becomes 8, 7 becomes 5, 5 becomes 4, 8 becomes 6, 6 becomes 5, 4 becomes 2, so that should be 31. So now you see not only how to do them, but some tips on error correction. You can see I make a lot of errors when I go fast, and I suspect you will too. So you fix them by doing the problem twice in 2 different sheets of paper and then comparing against each other to see which one is right. So good luck.